Hi everybody, I hope you are doing well. And today I will explain for you what is the anionic polymerization. Let's remember that polymerization is a chemical reaction to create or to form polymers from monomers. And this polymerization has two main mechanisms of reaction. The first one is addition, or termed as chain growth. The second one is condensation, or known as step growth. We already started the addition polymerization. We had together the free radical mechanism of addition polymerization, the cationic, and today we are going to talk about the anionic polymerization. So, from its name, anionic, so we expect that there is a formation of anion. The monomer will be activated when it is formed, when it is converted to carbonium ion or a negative ion or anion. This is a type of chain growth or addition polymerization. And the initiator, we usually know that in the addition polymerization, we have an initiation step. And for this initiation step to start, we need an initiator, which initiates the reaction by activating the monomer, which will go into the reaction by itself, accepting more and more monomers for the chain to grow and to grow. So here we need an anionic initiator. This anionic initiator, its role is to transfer its electrons or negative charge to the monomer. Once the monomer gets a negative charged group or the pair of electrons, it will be reactive and it will form a carbonium ion. The types of monomers that follow this rule of polymerization is vinyl monomers and cyclic monomers. For example, vinyl pyridine, butadiene, and hexamethyl cyclotrisilicosane. And another example is the rubbers. All of these are examples of the monomers, of the types of monomers that undergo polymerization through the anionic polymerization reaction. So they are type of monomers which are ready to accept electrons or accept a negative charge. Vinyl monomers, such as styrene or butadiene, cyclic monomers, such as epoxide and lactames. All of these are monomers that can undergo anionic polymerization reaction. What do you expect the steps of anionic polymerization? Can you remember? Yes, exactly. Perfect. You're excellent. As you remember, it is a type of addition polymerization. And addition polymerization has three main steps, which will be initiation, propagation, and termination. Initiation, propagation, termination. Initiation is the first step where the monomer is initiated or activated to take its way later to accept more monomers in the propagation steps. Termination, propagation is a step where the more monomers are added to the chain and the chain is keeping growing up. It is called the chain growth reaction. So there's a chain growth by adding more monomers until termination. Termination is the last step where there is a decision to terminate the reaction and stop the growth of the polymer chain. Initiation step in the anionic polymerization is started by the formation of carbanion ion, which is negatively charged carbon atom in the monomer. Here, The choice of the initiator depends on the reactivity of the monomer. So the choice of the initiator is critical. Each type of monomer, each monomer with a certain reactivity will require a certain initiator. So here the choice of the initiator is very critical. If you remember in the cationic polymerization where a carbonium ion is formed, what is critical in the reaction, in the initiation? Perfect. The choice of the solvent. So for the carbonium ion to be formed, the positive ion, or in the cationic polymerization, the choice of the solvent is very, very critical because we need a solvent which is not nucleophilic, so it couldn't trap the positive ion or the carbonium ion of the monomer, of the reactive monomer. Here in the anionic polymerization, the critical is the initiator. So if we need to classify the suitable initiator according to the monomer reactivity can be highly reactive. Monomer can be highly reactive, and these are highly electrophilic monomers, or intermediate, or has less reactivity. The highly reactive monomer, for example, cyanoacrylates, it needs a weakly nucleophilic initiator. Such as amine or phosphines or halides. While the intermediate monomers, which has an intermediate reactivity like the vinyl pyridine, it needs an intermediate nucleophile. The less reactive monomer, like styrene, it will need a strong nucleophile to be activated like butyl lithium. Initiation step can be either by two methods, either by electron transfer or by strong anions. The first method by electron transfer. So we have a monomer here, okay, which reacts with the metal, and we know that metals are readily lose electron, so they can lose an electron, which will be attracted by the monomer and form an anion, and the sodium metal will be positively charged. So by initiation by strong anions as initiator, here we have a nucleophilic initiator like amides, alkoxides, hydroxides, cyanides, phosphines, amines, and organometallic compounds like alkyl lithium compounds and the green, Grignard reagents and the Grignard reagents. In this case, we have a strong nucleophilic group or a strong anion, which will attack the monomer. And the double bond will be broken, and the result will be a negatively charged carbon ion or carbanion. And the functional group will bind to the monomer. This is the reactive monomer that will initiate the reaction and will take the reaction to the next step, which is propagation. The propagation, this is the longest, as we know, this is the longest step in the reaction. If we talk about timing, so propagation will take the longest time with the reaction because here the polymer is growing up, so it will take long time. In the propagation, more monomers will be added to the reactive monomers, and the chain will be reactive, accepting more monomers and keep growing. The length of the chain is increased in this step. So here we have this reactive monomer, which we get from the initiation step. The reactive monomer will attack another monomer, and the double bond will break, and the chain length is increased. The termination is the final step. This is a step where we say stop here and we need this polymer to be terminated. We don't need that chain to be increased more. So we need to terminate the reaction, stop the reaction. Another amine group will react with the reactive polymer. Now it is a polymer, but it is reactive, where it will lose a hydrogen and give it to the negative charge. So the negative charge will attract this hydrogen. And in that case, the polymer will become normal, neutral. So it is not reactive anymore to accept more monomers, leaving a negative amine group in the medium, which can attack another monomer if exists and follow another polymerization reaction. Let's recap what we have said today. Today, we explained the anionic polymerization. From its name, it's anionic, so there is a formation of anion, carbanion ion, or negative carbon ion. This is a type of addition polymerization. So its mechanism follows three steps: initiation, propagation, termination. And the choice of the initiator is critical, which depends on the reactivity of the monomer. This initiator will attack the monomer to turn the monomer into a negative ion. So once this carbon ion is formed, the monomer becomes reactive which is ready to enter the next step, which is propagation, where it can attract more monomers, and the chain will grow with the negative charge is transformed to the terminal carbon atom in the chain to be able to attract more monomers. After propagation, after certain length of the polymer, there is a termination step takes place where a hydrogen is attracted to the negative polymer. The polymer is now negatively charged. It's an open chain. It's not closed yet, not terminated yet. So if we have, for example, an ammonia molecule as an initiator. So one hydrogen from the ammonia will be attracted to the negative charge, and hence the polymer is formed and becomes neutral, and the reaction is terminated. That's all for today, guys. Thank you so much. Just to compare between the three lectures, they are very similar. The free radical cationic and anionic polymerization, they are very, very similar to each in the steps and in the mechanism. Just find the differences between them, and the idea will be crystallized in your head and will be easy for you. Thank you, guys. See you next video, and bye-bye.